Dear students, welcome to the third part of the electricity lesson. In the previous session, we understood electric potential, potential difference, and electric current respectively. In today's lecture, we are going to learn about electric circuits and their components as well as Ohm's law. Electric circuits and their components. So, to understand electric circuit, you must define the term called electric network. So, electric network is an interconnection of electrical components such as batteries, or you may call cells, resistors, capacitors, transformers, etc. So, electric network is the interconnection between the electrical components as such: batteries, resistors, capacitors, and transformers, and so on. So, electrical components are nothing but the components or the materials belonging to electrical network. Now, let's move on to the definition of electric circuit. Electric circuit is an electrical network giving a return path for electric current in it. So, electric circuit is an electrical network giving a return path for electric current in it. Let's draw a simple electric circuit. A simple electric circuit comprises of a battery, a plug key, an emitter, and a bulb or any other output device. Now, this is a symbol for battery. We will discuss the details in the short time. So, this is plug key, open plug key we call it as. This is emitter A, and this is bulb B. This is battery, this is plug key, this is emitter, and this is bulb respectively. When you switch on the supply, current starting from moving from battery positive to battery negative like this. So as a result, bulb will glow. When this supply is off, the bulb is going to off. So this is the simple arrangement of electric circuit to show a simple electric circuit. Remember, the diagram which is showing this is known as circuit diagram. The diagram showing electric circuit is known as electric circuit diagram. We call it as circuit diagram or electric circuit diagram. These diagrams definitely help the students to construct the circuit in a simple manner. Dear students, let's move on to electrical components in the circuits and their symbols respectively. So let's take a first electrical component, that is a battery or an electric cell. So this can be drawn a larger line and a smaller line with some amount of gap in between. So larger line is taken as positive and smaller line is taken as positive. This is the simple electric cell or a battery. Now if you connect in combination, generally to get the more potential difference, the people are going to connect it in series like this. Second one, that is the combination of cells. I am considering three different cells connecting in series like this. So this is the positive end of the first battery, this is the negative end of the first battery, this is the first end or positive end of the second battery, and this is the second end of second battery, third positive end of third and negative end of the third respectively. This is the combination of cells, especially in series. Now let's move on to the next part, that is plug key, or you may take it as initially open plug key. It is also called as a switch which is open. This is very simple. So this is called open plug key. It can be also drawn like this. This is the open plug key or open switch. Now, whenever the plug key is open or switch is open, there is no flow of current in the circuit. Now, closed plug key. Or you take it as closed switch. It can be drawn as, which is very similar to the above diagram, only change is a dot mentioned inside this bracket. Or in second case, you just continue with the dark mark like this. This is closed switch S. This is closed plug key K. Either you go for the above diagram or below diagram. This is also switch S. This is plug key K. Both are same. Next, a wire joint or joint in a wire. If two wires are connected, that can be shown like this. So wherever the joints are there, that portion is marked like this. This is called a wire joint or a joint in a wire. Now, a wire Now a wires crossing without joint. Wires crossing, or you call it as without joint. Let's imagine we are having two wires. One is moving like this inside the circuit and other one is moving like this. So you cannot connect these two because those two wires are different from one another. Therefore, you must put the thing like this. This is the indicator. The wires are moving without joint or without touching one another. Seventh one, electric bulb. So bulb can be symbolized like this. This is simple electric bulb written as B. Next, as we all know that bulb is the output device which gives us the light. And eighth one, fixed resistor. So this is the symbol for a fixed resistor. Next, a variable resistor or rheostat. A variable resistor, it is also called as rheostat. In this type of resistor, you can vary the range, vary the values from one range to another. It can be symbolized like this. The only difference to the above diagram is the arrow mark, which is indicator of the variable resistor. Rheostat can be symbolized like this also. This line is indicator that it is sliding on these two edges, therefore you will get the varied resistance. Next, 10th one, ammeter. Ammeter can be symbolized as like this, plus, minus, and in between there is a circle which is containing the term A. So ammeter is the device which is used to measure the electric current. Next, voltmeter. Voltmeter is the device to measure the potential difference, and this is symbolized like this. As we already aware that ammeter has to be connected through to the wire, whereas voltmeter connected across the two ends of the wire. Means this is through, this is parallel. Next, that is fuse. Fuse is a protecting device which is used to give some protection to the electric circuit. It is symbolized like this. Next, galvanometer. Galvanometer is the device used to measure the electric resistance through deflection. Next, a capacitor. Capacitor is the device used to store electrical energy. Remember, capacitor is having the symbol two parallel lines, whereas battery is one larger and other line is smaller. don't get confused while drawing the battery as well as capacitor. Please take care of. 15th one, transformer. Transformer is the device which is used to change the voltage from higher to lower or lower to higher, a step up or step down the voltage. That is the device called transformer. So these are all the symbols, few symbols. Keep in mind there are vast amount of components and their symbols exist in electrical circuits. So please take care of these things. Dear students, let's move on to the next part, that is Ohm's law. We are already know about electric potential and electric current respectively. Is there any relation between that? The answer is yes, that is Ohm's law. Ohm's law gives us the relationship between electric potential and electric current respectively. In the year 1827, the German scientist George Simon Ohm, who formulated this law, called as Ohm's law. Let us state the Ohm's law. At constant temperature, the potential difference between two ends of the wire or conductor is directly proportional to electric current flowing through it. So this law can be stated as, at constant temperature, if we maintain the constant temperature, the potential difference across the two ends of the wire is directly proportional to the current flowing through it. If V be the potential difference and I be the electric current, then according to the law, V proportional to I. V proportional to I. If you remove this proportionality constant, you leave with a resistance. You leave with a proportionality constant called as resistance, where R is known as proportionality constant, or it is called as resistance. Now let us define the property of resistance. It is the property of the conductor which resists the flow of current. That is known as electric resistance. So the property of the conductor which resists the flow of current is known as electric resistance. From the above relation, it can be written as R is equal to V by I. So this is the direct indication that resistance is varied directly with voltage and varied indirectly or inversely with current. Which means if you increase the potential difference, resistance is going to increase. If you decrease the voltage, resistance is going to decrease. If you increase the electric current, then you have an inverse relation. Therefore, current resistance decreases as the current increases. Current decreases means resistance increases. That's the relation between R and V, R and I respectively. Now we are moving to the next point, that is SI unit of resistance, that is given by ohm. This is the term named after George Simon Ohm, who formulated this law. It is written small letters OHM or a Greek symbol like this, that is the symbol for ohm. Now definition of 1 ohm. If we maintained 1 ohm of potential difference and 1 ampere of electric current, then we say there is 1 ohm of resistance. If the potential difference across the conductor is 1 volt and electric current of 1 ampere, then we say there is 1 ohm of resistance. That is 1 ohm of resistance can be written as 1 volt divided by 1 ampere, therefore 1 volt per ampere. So 1 ohm is equal to 1 volt per ampere. Note that this law is very important, as in many practicals it is necessary to change the electric current. Please take care of.